Hello everyone, this is Ramachandran, math tutor from Online Math for All. In this video, we are going to see the fourth set of 10 hard SAT math problems with step-by-step solution for each problem. Okay, let's go to the problems. The table shows three values of x and their corresponding values of y for the linear relationship between x and y. The x-intercept of the line occurs when x equals to -4. The number d is a negative constant. The number k is a constant. What is the value of dk? Okay, there is an information. The x-intercept of the line occurs when x equals to -4. We know that at the x-intercept of any line, the y coordinate is 0. And we have this value -4 for x over here. So when x equals to -4, y must be 0 because we have the x-intercept at x equals to -4. So instead of this 4k positive 6d, we can consider 0 over here. So there is a 4k positive 6d, 6d equals to 0. Now let's solve for k in this equation. Then we have to subtract 6d from both sides of the equation. Then this positive 6d, negative 6d will cancel out. I am getting 4k equals to negative 6d. Let me divide both sides of the equation by 4. Then this 4 will cancel out. Here 2 goes into 4 2 times and 2 goes into 6 3 times. I am getting k equals to negative 3d over 2. Okay, here, once I get the value of d, I can plug in over here and get the value of k. Then we have to multiply the values of k and d to get the value of dk. Now let's consider the information we have over here. There is linear relationship between x and y. The graph of the linear relationship is always a line, and the slope of a line is a constant. That is, when we get the slope of a line at any point on the line, it will be same. Okay, now let me get the slope of the line using the first 2 points in the table. Okay, now let me write the first 2 points are -7, d positive 3, and the second point is -4, 0. Okay, I take the first point as x1, y1 and the second point as x2, y2. When we have 2 points on a line, there is a formula to get the slope. That is m equals to y2 negative y1 divided by x2 negative x1. Now let me plug in the values over here. For y2 we have 0, negative. For y1 we have d positive 3. And for x2 we have -4, negative. The value of x1 is -7. Okay, now let me continue over here. M equals to let's distribute this negative sign to this d and positive 3. Then I'm getting negative d, negative 3 divided by -4. Negative times negative is positive 7. Then I'm getting m equals to negative d, negative 3 divided by 3. Okay, here I got the slope of the line m, that is a negative d, negative 3 over 3. Okay, now let me get the slope of the same line using the next 2 points, that is second point and third point. Let me write over here -4, 0, and the other point is 1, negative 3d, 8. I take this is x1, y1 and this is x2, y2. Now let me use the same formula. In this formula, we have to plug in the values for y2, y1, x2, x1. Then I'm getting 8, negative 0 in denominator, 1, negative 3d, negative. The value of x1 is -4. I'm getting m equals to 8, negative 0 is 8 and 1, negative 3d, positive 4. Then I'm getting m equals to 8 divided by, when I combine this 1 and 4, I'm getting 5, negative 3d. Okay, here I got the slope of the line in 2 ways. That is using the first 2 points and using the next 2 points. As I said already, the slope of a line is a constant. That is, at any point on the line, the slope will be same. So the slope I got over here, the slope I got over here must be equal. Okay, now let me equate the two slopes. Then I'm getting negative d, negative 3 over 3 equals to 8 over 5, negative 3d. Now let's do some cross multiplication. Then I'm getting negative d, negative 3 times 5, negative 3d. On the right side, we have 8 times 3. Now we can multiply these two binomials using the FOIL method. Let me multiply the first terms, negative d times 5. I'm getting negative 5d. Negative d times negative 3d will be positive 3d square. Negative 3 times 5 is negative 15. And negative 3 times negative 3d is positive 9d equals to 24. Okay, now let's rearrange the terms on the left side over here. Let me write this 3d square at first. Then we can combine this negative 5d, positive 9d. I am getting positive 4d. Then we can write the constant negative 15 equals to 24. Let me subtract 24 from both sides of the equation. Okay, let me do it. Then this positive 24, negative 24 will cancel out. I am getting 3d square, positive 4d. When I combine negative 15 and negative 24, I am getting negative 39. On the right side, we have 0. Here, we have a quadratic equation in standard form in terms of the unknown d. I think this quadratic equation can be solved by factoring. For that, we have to multiply the constant term by the coefficient of d square. When I multiply negative 39 and 3, I am getting negative 117. Now, I have to get two factors over here such that the product of the two factors equals to negative 117 and the sum of the two factors equals to the coefficient of d, that is a positive 4. I think positive 13 and negative 9 will work. When I multiply them, I am getting negative 117. When we add them, we get a positive 4, that is a coefficient of d. Further, we have to divide both the factors over here by the coefficient of d square, that is 3. Okay, here 13 is not divisible by 3, so we have to take this one as it is. When I divide this negative 9 by 3, I am getting negative 3. Okay, here to get the two values of d in this quadratic equation, what I have to do is I have to change the signs of these two factors. Now let me consider the first one. It's already positive. When I change the sign, it will be negative. That is the first value of d is negative 13 over 3. Now to get the second value of d, I have to change the sign of this factor. Already it's negative. When I change the sign, it will be positive 3. Okay, here I got two values for d. One is negative 13 over 3 and other one is positive 3. But there is an information that number d is a negative constant. Since d is a negative constant, we can reject the positive value of d. We can consider the negative value of d, that is negative 13 over 3. Okay, now let me erase this stuff and continue the problem. Let's plug in this value negative 13 over 3 for d over here to get the value of k. Okay, let me do it. That is k equals to negative 3 times negative 13 over 3 divided by 2. Here 3 goes into 3 one times and 3 goes into 3 one times. K equals to negative times negative is positive. 1 times 13 is 13. There is 13 over 1. It can be written as 13. In denominator, we have 2. Okay, here I got the value of k. Already we have the value for d. Now, what we have to do is we have to get the value for dk, that is d times k. D times k equals to the value for d is negative 13 over 3 and the value of k is 13 over 2. Then d times k equals to negative 13 times 13 is negative 169 and 3 times 2 is 6. Therefore, the value of d times k is negative 169 over 6. F of x equals to ax squared into 7x positive c. The function f is defined above where a and c are constants. The graph of y equals to f of x is a parabola that has a vertex at the point h comma k where h and k are constants. If f of negative 9 equals to f of 92 and c is greater than 0, which of the following must be true? Here we have two statements. One is a less than 83/4 and other one is k is greater than 16. We have to check whether the first statement is true or the second statement is true or both of them true or both of them are not true. Okay, now let me consider the information we have over here. That is f of negative 9 equals to f of 92 and also we have an information that y equals to f of x. That is, this f of negative 9 is the value of y. This f of negative 2 is also the value of y. Actually, this is the value of y when x equals to negative 9 and this is the value of y when x equals to negative 2. Here, for this quadratic function, for two different values of x, we have the same value of y. In a quadratic function, for two different values of x, when we have the same value of y, then the average of these two x values must be the x coordinate of the vertex, that is h. Okay, now let me get the average of these two x values, that is negative 9, negative 2. I have to add them and divide by the number of values, that is 2. Then I am getting h equals to negative 11 over 2. Okay, here I got the x coordinate of the vertex. Okay, now let's consider the given quadratic function. It is in standard form, that is f of x equals to ax square positive bx positive c. When we have a quadratic function in standard form, there is a formula to get the x coordinate of the vertex h, that is negative b over 2a. We have to take negative sign and consider the coefficient of x, that is b. It should be taken in numerator. It has to be divided by 2 times the coefficient of x square. Okay, now let's do the same thing for this quadratic function to get the x coordinate of the vertex, that is h equals to, we have to take negative sign. Now we have to take the coefficient of x, that is negative 7 divided by 2 times the coefficient of x square, that is a. Then we get h equals to negative times negative is a positive, that is we get 7 over 2a. Okay, here I got the x coordinate of the vertex. Already we have the x coordinate of the vertex. So we can equate them. That is 7 over 2a equals to negative 11 over 2. Now let's take a reciprocal on both sides. Then I'm getting 2a over 7 equals to negative 2 over 11. Now to solve for a in this equation, I have to get rid of the fraction 2 over 7 which is multiplied by a. Now let me multiply both sides of this equation by the reciprocal of the fraction, that is 7 over 2. Let me do it. Then this 7 will cancel out, 2 cancel out. I'm getting a on the left side. Here this 2 will cancel out. I'm getting negative 7 over 11. Okay, now let me get the exact value of negative 7 over 11. When I divide 7 by 11, I'm getting a very long decimal. Let me, that is 0.6368, it keeps going. Let me round this value to the nearest hundred, then I'm getting negative 0.64. Okay, here I got the value of A, that is a negative 0.64. Okay, now let me consider the first statement over here, that is A is less than negative 3/4. What is the value of this negative 3/4? That is exactly negative 0.75. That is A is less than negative 0.75. Now let me take the number line and let me take 0 over here and let me take negative 1 over here, and we'll have this value negative 0.75 about here. Let me mark it. And we have this value negative 0.64 to the right of negative 0.75. Let me take it over here, negative 0.64. Always the value we have on the right side is greater than the value on the left side on the number line. So clearly negative 0.64 is greater than a negative 0.75. But here the first statement says the value of A is less than negative 0.75, but the value we got over here for A is greater than this value negative 0.75, because we have this value to the right side of negative 0.75 in the number line. So the first statement A less than negative 3/4 is incorrect. Okay, now we have to verify the second statement. Now let me erase this stuff and continue the problem. Okay, already we got the value of x coordinate of the vertex, and that is the value of h that is equal to negative 11 over 2, and also the value of a that is equal to negative 7 over 11. Now let me write the quadratic function in vertex form, that is f of x equals to a times x negative h whole square positive k f of x equals to, now let's plug in the values of a and h over here. It is negative 7 over 11 times x negative, and the value of h is negative 11 over 2 the whole square positive k. Okay, f of x equals to negative 7 over 11 x, and negative times negative is positive 11 over 2 the whole square positive k. Now we have to expand the square of the binomial over here. For that, we can consider the algebraic identity, that is a positive the whole square. The expansion of the square of the binomial over here is a square positive 2ab positive b square. Okay, now when I compare this one and this one, at the place of a we have x, at the place of b we have 11 over 2. Now to get the expansion for this one, we can consider the trinomial over here. In this trinomial, for a we have to plug in x, and for b we have to plug in 11 over 2. Okay, now let me do it. Then I'm getting f of x equals to negative 7 over 11 times x square positive 2ab, that is 2 times x times 11 over 2 positive b square, that is 11 over 2 the whole square positive k. Okay, now let me continue over here. F of x equals to negative 7 over 11 times x square, and here this 2 will cancel out. I'm getting positive 11x, and when I evaluate the value of this one, I'm getting 121 over 4 positive k. Okay, then f of x equals to, we can distribute this negative 7 over 11 to all the terms we have inside the parenthesis. Then I'm getting negative 7 over 11 x square, and when I multiply this negative 7 over 11 and positive 11x, I am getting negative 7x, because when I multiply this one and this one, this 11 and 11 will cancel out. Okay, now let's multiply this one and this one, that is a negative times a positive is negative. Okay, now let me do this multiplication separately. That is 7 over 11 times 121 over 4. 11 goes into 11 one times, and 11 goes into 121 11 times, and 7 times 11 is 77. That is we get 77 over 4 positive k. Okay, here I wrote the quadratic function in vertex form. Finally, I simplified the quadratic function to the standard form, in which we have the given quadratic function. Okay, now let's compare the quadratic function we got over here with the given quadratic function. Let me write the given quadratic function over here. That is f of x equals to ax square negative 7x positive c. We have a x square term, x square term, x term, x term, and this is a constant term. Here the constant term is c. At the place of c, we have negative 77 over 4 positive k. So that is the value of c equals to negative 77 over 4 positive k. Now, let me consider the information we have over here, that is the value of C is greater than 0. Now, let me plug in this stuff for C over here, then I'm getting negative 77 over 4, positive K greater than 0. Now, let me solve for K in this equation. For that, we have to add 77 over 4 to both sides of the equation. When I do so, this negative value, positive value will cancel out. I am getting K greater than, when I combine this 0 and positive 77 over 4, I am getting positive 77 over 4. Okay, here when I simplify this value, I am getting 19.25. That is, any value greater than 19.25 can be considered for K. Okay, now let me consider some values for K which meet this inequality. Then we can consider 19.3 or 19.5 or some integers like 20, 21. So all the values I have taken out here are greater than 19.25. So these values satisfy this inequality. Now let's go to the statement 2 over here. Statement 2 says K has to be greater than 16. Okay, now we have to check the values we have taken over here for K which meet this inequality will satisfy the inequality we have in the second statement. 19.3 will satisfy this inequality because 19.3 is greater than 16. So all the values we have for K with this inequality will be greater than 16. So the second statement is true. In the given two statements, only the second statement is true. In the given answer choices, we have to find the one where we get the second statement. That is in answer choice B. Therefore, the correct answer choice for this question is B. The triangle inequality theorem states that the sum of any two sides of a triangle must be greater than the length of the third side. A triangle has side lengths of 4x positive 20, 2x positive 8 and 7x negative 11, which inequality represents all possible values of x. Okay, according to the triangle inequality theorem, when I add the lengths of any two sides of the triangle, always it will be greater than the length of the third side. Okay, now let me take the lengths of the first two sides we have over here and add them. Okay, let me do it. That is 4x positive 20 positive 2x positive 8. Here I have added the lengths of the first two sides. It must be greater than the third side. That is greater than 7x negative 11. Okay, now let me add the length of the second side, length of the third side, that is 2x positive 8, positive 7x negative 11. Okay, here we have the sum of the lengths of the second side and third side. It must be greater than the length of the first side, that is greater than 4x positive 20. Okay, now let me add the lengths of the first side and the third side, that is 4x positive 20, positive 7x negative 11. It must be greater than the length of the second side, that is 2x positive 8. Okay, now let's do some simplification in the first inequality over here. That is, we can simplify the expression on the left side. When I combine this 4x and 2x, I am getting 6x, and when I combine this 20 and 8, I am getting 28 greater than 7x negative 11. Okay, now let me subtract 7x from both sides of this inequality and also subtract 28. Let me do it. Then this positive value, negative value will cancel out. Here positive value, negative value will cancel out. When I combine positive 6x and negative 7x, I am getting negative 1x greater than, when I combine these two values, I am getting a negative 39. Okay, here I am trying to solve for x, but here x contains a negative sign. To get rid of the negative sign, we can multiply both sides of this inequality by negative 1. That is negative 1 times negative x and negative 1 times negative 39. In an inequality, when I multiply or divide both sides by the same negative number, we have to flip the inequality sign. Okay, here we have greater than. When I flip it over, it will become less than. Okay, negative 1 times negative x is a positive x, less than negative 1 times negative 39 is a positive 39. Okay, this is the result I am getting from the first inequality we have over here. Okay, now let's do some simplification in the second one. That is, we can combine the like terms on the left side over here. When I combine this 2x and 7x, I am getting 9x. And when I combine this 8 and negative 11, I am getting negative 3 greater than 4x positive 20. Now, let me subtract 4x from both sides of the inequality and add 3 to both sides. Let me do it. Now, this negative 3 positive 3 will cancel. Positive 4x negative 4x will cancel out. When I simplify this one, I am getting 5x. On the right side, I am getting 23. Now let me divide both sides of this inequality by 5. Then this 5 will cancel out. I am getting x greater than 23 over 5. Okay, now let me do some simplification in the third inequality over here. Let's combine the like terms, 4x and 7x, and I'm getting 11x. When I combine this positive 20 and negative 11, I'm getting positive 9 greater than 2x positive 8. Okay, now let me subtract 9 from both sides of this inequality and also 2x. Let me do it. Then this positive 2x, negative 2x will cancel. Positive 9, negative 9 will cancel out. When I combine 11x and negative 2x, I'm getting 9x greater than, when I combine positive 8 and negative 9, I'm getting negative 1. Let me divide both sides of this inequality by 9. Then this 9 will cancel out. I'm getting x greater than negative 1 over 9. Okay, here I got three results when I apply a triangle inequality theorem for the given three side lengths. And particularly when I consider the third result, that is x is greater than negative 1 over 9, here we have both negative values and positive values for x. And let's consider the length of the third side over here, that is 7x negative 11. Here, what can be the possible value of x over here? The value of x has to be greater than 1, because if the value of x is equal to 1 or less than 1, then this part will become negative. For example, if I consider x equals to 1, then 7 times 1 is 7, 7 negative 11 is a negative 4. That is, the length of the third side of the triangle is negative. It's not possible, because the length of the side of any triangle can never be negative. So here the value of x has to be greater than 1. But here in this inequality, we have both negative values and positive values. So it does not give any clear information about the values of x. So we can reject this result. Okay, now let's consider the result we have in answer choice A, that is x less than 39. And we may think we have this result over here. So answer choice A may be correct. But when I think about this x less than 39, x can take any value less than 39, like 38, 37, it goes like even negative value also can be considered according to this stuff. Because when I consider 0 or negative 1, negative 2, that is also less than 39. So it does not make sense. So we can reject answer choice A. Now we have three more answer choices, B, C and D. In each of these three answer choices, we have component inequality. So we have to get a component inequality from the two results we have over here. For that, we have to identify the smaller one of these two values. Okay, here we have an integer. Now let's get the value of this 23 over 5. The value of this fraction 23 over 5 is 4.6. Clearly, this is a smaller one. Since this is a smaller one, we have to get this value on the left side of the inequality. That is, we have to switch these two quantities. Then I'm getting 23 over 5 on the left side and x on the right side. In an inequality, when I switch the quantities, I have to flip the inequality sign. When I flip it over, it will become less than. Now, let's combine these two inequalities. Now, let me write the smaller value first. That is 23 over 5 less than x. Now we have to combine this one over here. Already we have x, then we can take the less than and 39. So this is a component inequality. I get it from the two results we have over here. And when I go over the answer choices, here we have an integer, here we have an integer. In answer choice C also we have integer over here, integer over here. In D also we have the same thing. But in this inequality, we have a fraction over here. To make this fraction as an integer, we have to get of the denominator 5. For that, we have to multiply all the three quantities of this inequality by 5. Okay, let me do it. When I multiply this one by 5, I am getting 23 less than. When I multiply this x by 5, I am getting 5x. When I multiply this 39 by 5, I am getting 195. Okay, this is the result I am getting, and we find this stuff for 23 less than 5x less than 195 in answer choice D. The correct answer choice for this question is D. In the given circle, point B is the center, point A, C and D lie on the circle, point B lies on line segment AC, line EA is tangent to the circle at point A, the diameter of the circle is 240 centimeter, the length of segment B is twice that of segment AB. If minor arc CD is K by centimeter, what is the value of K? Okay, here we have an information that is this B is the center of the circle and EA is tangent to the circle over here. The diameter of the circle is 240 centimeters. Okay, so the line segment AC over here represents the diameter because it's a chord is passing through the center of the circle. So it represents the diameter and its length is 240 centimeter. And the length of segment B, so the segment B is over here, is equal to twice that of segment AB. So to get the length of this segment B, we have to take 2 times of the length of this segment AB. Actually, this AB represents the radius of the circle because it connects the center of the circle and a point on the circle. Already we know that the diameter is 240. Then to get the radius, what we have to do is we have to take half of this. Half of 240 is 120. So the length of the segment AB is 120. Then what is the length of this segment BE? According to the information, the length of B is twice the length of AB. So twice 120 is 240. So the length of this line segment B is 240. And the question says EA is the tangent to the circle. And it's a tangent drawn from the external point E. When we draw a tangent to a circle from the external point, at the point of tangency, the angle between the tangent and radius is always right angle. So here we have a right angle. Now this triangle ABE is a right triangle. In this right triangle, B is the hypotenuse because it is opposite to the right angle. And the length of the hypotenuse is 2 times the length of one of the other two legs over here. Okay, in a right triangle, if the length of the hypotenuse is 2 times the length of one of the other two legs, then it is 30, 60, 90 special right triangle. Since we have 2 times of this leg is equal to the hypotenuse, we have to consider this leg as the shortest leg of this triangle, and the interior angle which is opposite to this shortest leg has to be 30 degrees, this interior angle, and this is the smallest interior angle of this triangle. Okay, now let's consider the 3 interior angles of this right triangle ABE over here. As I said already, it's a 30, 60, 90 special right triangle. Here we have 30 degrees and here we have 90 degrees, that is right angle. Then this interior angle has to be 60 degrees. So that the 3 interior angles will add up to 180 degrees. Okay, if this is 60 degrees, then what is the measure of this angle over here? We know that it's a straight angle. Always as a straight angle measures 180 degrees. If this part is 60 degrees, then this part has to be 120 degrees. Now let's consider the minor arc CD over here. Here I got the central angle of the minor arc, that is 120 degrees. And here we have the length of the minor arc, that is K pi. Okay, let me write the stuff over here. That is the length of minor arc CD equals to K pi. And we have the formula to get the length of an arc, that is theta divided by 360 degrees times the circumference of the circle, that is 2 pi r, which is equal to K pi. This theta is the central angle of the arc. Here the central angle of the arc is 120 degrees. We can plug in this 120 degrees for theta over here. Let me plug in, divided by 360 degrees times 2 pi times, here this r represents the radius of the circle. Already we have the radius of the circle, that is 120. We can plug in this 120 for r over here equals to K pi. Okay, now we have to solve for K in this equation. 120 goes into 120 one times and 120 goes into 360 3 times. Here 3 goes into 3 one times and 3 goes into 12 4 times, and we can take this 0 over here. Okay, now when I multiply this 2 pi and 40, I am getting 80 pi on the left side. On the right side, we have K pi. Now let me divide both sides of this equation by pi. Then this pi will cancel out. Here the same thing. Then we get 80 equals to K. Okay, here I got the value of K. It is 80. A circle is centered at point O with coordinates 0, 0 in the xy plane. The circle contains point A with coordinates 25, 0 and point B with coordinates k, 24, where k is a negative constant. What is the value of cosine of angle AOB? Okay, first let me draw a circle in an xy plane. Here I've drawn a circle in an xy plane. Okay, now let me mark its x-axis and y-axis. And the center of the circle is O with the coordinates 0, 0. That is the origin. It's over here. And we have the point A with coordinates 25, 0 on the circle. Okay, since the y coordinate over here is 0, then we'll have this point at the x-axis and also on the circle. Then we'll have the point A over here. Because the x coordinate over here is positive, so we'll have this point 25, 0 on the positive side of x-axis. We'll have the value 25, and this is point A of 25, 0. Now let's consider the point B with coordinates k, 24. Here the y coordinate is 24, it's a positive value, and the x coordinate is k, which is a negative constant. So here x coordinate is negative, y coordinate is positive. Then we'll have this point B in the second quadrant. Only in the second quadrant over here, the x coordinate will be negative and y coordinate will be positive. At somewhere else on the circle in the second quadrant, we have to mark the point B over here. Let me mark the point B, where the coordinates are k and 24. Okay, now let me draw the angle AOB. Let me draw it over here. Okay, here I've drawn the angle AOB. For this angle AOB, we have to find the value for the trigonometric ratio cosine. Okay, now what I'm going to do is I'm going to draw a perpendicular line from the point B to the x-axis over here. When I do so, this perpendicular line will intersect the x-axis at right angle over here, and let me mark this is point C. Okay, here we get a right triangle OBC over here, and already we know that this is a measure of angle AOB, and this OB is the terminal side of the angle AOB. And here I find an acute angle between the terminal side OB and the horizontal axis. Okay, here we have the angle AOB, and here I find an acute angle between the terminal side of angle AOB and the horizontal axis. Then this acute angle is called the reference angle of the original angle AOB. Let's name this reference angle as alpha. Okay, here whatever result I am getting for this reference angle, the same can be applied for the original angle AOB over here. When I want to find trigonometric ratios like sine or cosine for the original angle AOB, I can get the value of the same trigonometric ratio for the reference angle, and then we have to decide the sign of the result based on where we have the terminal side of the original angle. Okay, here we have to find the value of cosine of angle AOB. We know that alpha, this acute angle, is a reference angle for this angle AOB over here. Okay, instead of getting the value of cosine for this angle, let me get the value of cosine for this reference angle alpha. According to Secato, the formula to get the value of a trigonometric ratio cosine is adjacent side divided by hypotenuse. Okay, here we have the angle alpha, and the side which is opposite to this angle alpha is called opposite side, and this is a hypotenuse because it is opposite to the right angle, and this is hypotenuse OB, and the name of the third side is called adjacent, that is OC. Okay, now to get the value of cosine alpha, I need the length of adjacent side, that is the length of this line segment OC, and the length of the hypotenuse OB. Okay, here we have the value 25 on the x-axis, and OA is a line segment which connects the center of the circle, a point on the circle. So this OA represents a radius, and the length of the radius of the circle is 25. So here this line segment also represents the radius of the circle. So the length of the hypotenuse of this triangle is 25. Still we need the length of adjacent side to get the value of cosine alpha. Okay, how do you have to get the length of this adjacent side? That is the length of the line segment OC. Now let me consider the y-coordinate of the point B over here, that is 24. Then we have the value 24 on the y-axis over here. What is the length of this line segment? That is 24. The same length we have for this line segment BC, that is the length of the opposite side, 24. Okay, here in this right triangle OBC, I have the length of the hypotenuse, that is 25. I have the length of the opposite side, 24. Here we can get the length of this adjacent side OC using the Pythagorean theorem. Okay, now let me write Pythagorean theorem in this right triangle OBC to get the length of this side OC. So that is the sum of the squares of two legs is equal to the square of the hypotenuse. Let me write over here OC square positive CB square equals to OB square. Okay, let me write over here. For OC, I do not know the length. That's what I have to find. For CB, that is for opposite side, we have the length, that is 24. That is 24 square. And for OB, we have the length, that is hypotenuse, 25 square. Okay, let me do it. OC square positive. The evaluation of this one is 576, and the evaluation of this one is that is 25 square is equal to 625. Let me subtract 576 from both sides of this equation. When I do so, this positive value, negative value will cancel out. I am getting OC square on the left side. On the right side, when I simplify this one, I am getting 49. Now to get rid of the exponent 2 over here, we have to take square root on both sides of this equation. On the left side, this square root and square will cancel out. I am getting OC. And usually when we take square root on both sides of an equation, one of the square roots will cancel out. And for the other square root, we will consider positive or negative sign. But here on the left side, we have OC, which represents the length of one of the sides of the triangle. It cannot be negative. So we can consider only positive sign for this one. So equals to here, when I take square root of 49, I am getting 7. Okay, here I got the length of this line segment OC, that is 7. It is length of the adjacent side is 7. Okay, now let me plug in 7 for adjacent side. and 25 for hypotenuse. Okay, here I got the value of cosine alpha, but our aim is to get the value of cosine of angle AOB. Okay, now let me write the stuff over here. That is cosine of angle AOB. Now to get the value of cosine of angle AOB from this result, we have to consider the terminal side of this angle AOB. Already we know that the terminal side of the angle AOB is OB that we have in the second quadrant. And here we have first quadrant, here we have third quadrant, and here we have fourth quadrant. And we can consider the ASTC concept. That is, we have A for the first quadrant, and S for the second quadrant, C for the third quadrant, and T for the fourth quadrant. Okay, here we have the terminal side of the angle AOB in the second quadrant, and for second quadrant we have S. S means a trigonometric ratio sine and its reciprocal cosecant. Both of them are positive, the rest are negative. Rest means cosine, tangent, secant, cotangent, all of them are negative. Here we have cosine. So in the second quadrant, cosine is negative. Since cosine is negative, we have to consider this result with a negative sign for the value of cosine of angle AOB. So that is a negative 7/25. 5x square negative 40px positive 5y square positive 70py equals to 325p square. In the xy plane, the graph of the given equation is a circle where p is a constant. The center of the circle is negative 8, 14. If a square is inscribed in the circle, what is the area of the square? First, let me draw a circle in which a square is inscribed. Here I have drawn a circle in which a square is inscribed. And here we have the center of the circle, that is negative 8, 14. Now let me draw the diameter of the circle. Let me draw a diameter. Okay, here I have drawn a diameter for the circle. Actually, the diameter I have drawn over here represents the diagonal of the square. When I know the length of the diagonal of a square, we can use the formula d square over 2 to get the area of the square. This is the formula we have to get the area of a square when we know the length of the diagonal. Actually, this lowercase d represents the length of the diagonal we have over here. Okay, now my aim is to get the diameter of the circle. Once I get the diameter of the circle, that can be considered as the length of the diagonal. Then we can plug in that value for d over here and get the area of the square. Okay, how do you have to get the diameter of the circle? Let's consider the given equation of a circle over here. It's almost in general form. Now let me consider the equation of a circle in general form. That is x square positive y square positive 2gx positive 2fy positive c equals to 0. This is the equation of a circle in general form. When we have the equation of a circle in this form, there is a formula to get the center of the circle. The center of the circle is negative g comma negative f. And there is a formula to get the radius of the circle, that is square root of g square positive f square negative c. We can get the values of g and f from the coefficients of x and y respectively, and we can get the value of c from the constant term. Now what we have to do is we have to get the given equation exactly in this form, so that we'll be able to get the values of g, f and c. Then we can get the radius of the circle. Once we get the radius of the circle, it can be multiplied by 2 to get the diameter of the circle. Then that is the length of the diagonal of the square. Okay, now let me take the given equation and write it exactly in this form. Okay, here we can rearrange the terms on the left side. That is, first we can write 5x square. Then we can write y square term, that is a positive 5y square. We can write the x term negative 40px, then y term positive 70py. And we have to make the right side 0. For that, we have to subtract 325p square from both sides of the equation. Then we have negative 325p square on the left side over here, and the right side 0. Now, when I consider the equation over here, the coefficient of x square is 1, the coefficient of y square is also 1. But here, the coefficients of both x square and y square are 5. So we have to make these coefficients as 1. For that, we have to divide each term of this equation by 5. Okay, now let me do it. Divided by 5, divided by 5, here divided by 5, divided by 5, divided by 5, and the right side 0 is also divided by 5. Okay, here this 5 will cancel out. Here the same here, we get x square positive y square negative. When I divide this 40 by 5, I am getting 8, that is 8px. And when I divide this 70 by 5, I am getting 14, that is a positive 14py. Negative, when I divide this 325 by 5, I am getting a 65, that is 65p square, and the right side 0 divided by 5 is 0. Now we have the given equation of circle exactly in this form. Okay, now let's consider the coefficient of x over here. That is negative 8p. Here the coefficient of x is 2g. At the place of 2g, we have negative 8p. Then we have 2g equals to negative 8p. And at the place of 2f, that is coefficient of y, we have 14p. Then we have 2f equals to 14p. And at the place of c, we have negative 65p square. Then we have c equals to negative 65 p square. Okay, here let me divide both sides of this equation by 2 to solve for g. This 2 will cancel out. I am getting g equals to 8 over 2 is 4. That is negative 4p we have on the right side. Let me divide both sides of this equation by 2 to solve for f. Then I am getting f equals to 7p. Okay, now let's consider the center of the circle we have over here, negative 8 comma 14. And here we have the formula for center, that is negative g comma negative f. So then we can write negative g comma negative f equals to negative 8 comma 14. Okay, here 2 points are equal. Whenever 2 points are equal, we can equate the x coordinates and also the y coordinates. When I equate the x coordinates, I am getting negative g equals to negative 8. And when I equate the y coordinates, I am getting negative f equals to 14. Now to get the value of g, we have to multiply both sides of this equation by negative 1 to get of the negative sign that we have in front of g. Okay, when I multiply this one by negative 1, I am getting g. When I multiply this negative 8 by negative 1, I am getting positive 8. Do the same thing over here. Let's multiply both sides by negative 1. Then I am getting f on the left side. When I multiply this 14 by negative 1, I am getting a negative 14. Okay, here I got the values of g and f. I can plug in these values over here, but still we need the value of c to get the radius. How do you have to get the value of c? Here already we got the value of c, but it contains an unknown p. Okay, now once we get the value of the unknown p, we can plug in over here and get the value of c. Okay, here we know the value of g, that is 8. We can plug in this value 8 for g over here and get the value of p. Okay, now let me do it. That is 8 equals to negative 4p. Let me divide both sides by negative 4. Then this negative 4 will cancel out. 8 divided by negative 4 is a negative 2. On the right side, we have p. Here I got the value of p, that is negative 2. We can plug in this value negative 2 for p over here. Then I'm getting c equals to negative 65 times negative 2 the whole square. C equals to negative 65 times, the evaluation of this one is 4. C equals to negative 65 times 4 is negative 260. Okay, here we have the values of G, F and C. Now we can plug in the values over here and get the radius of the circle. Okay, now let me erase the stuff and continue the problem. Let's plug in the values of G, F and C over here in this formula to get the radius. That is the radius of the circle equals to square root of 8 square, positive negative 14 the whole square, and negative the value of C is negative 260. Okay, r equals to square root of the value of 8 square is 64 and the value of negative 14 the whole square is 196. Negative times negative is positive 260. Okay, r equals to square root of, when I add all these three values, I am getting 520. Okay, here I got the value of r, that is 520. Now let's find the diameter of the circle. That is the diameter of the circle is equal to 2 times the radius. Then we get d equals to 2 times square root of 520. Okay, here I got the diameter of the circle. So the diameter of the circle is the length of the diagonal of the square. Okay, now let's get the area of the square. Okay, let me write the stuff over here. Area of square equals to, the formula is d square divided by 2. That is the diagonal, the length of the diagonal has to be squared and it has to be divided by 2. Now we got the length of the diagonal of the square, that is 2 times square root of 520. Let me plug in over here. 2 times square root of 520, the whole square divided by 2. Okay, here two values are multiplied and there is a common exponent. Now we can take this exponent separately for each value and multiply the results. Okay, when I take this exponent 2 for this 2, I am getting 4. And when I take this exponent 2 for the square root, and this square root and square will cancel out, I am getting 520. In denominator, we have 2. Here 2 goes into 2 1 times and 2 goes into 4 2 times. Okay, here 2 times of 520 is 1040. Therefore, the area of the square is 1040 square units. The speed of an object is increasing at a rate of 33 inches per second square. What is the rate in miles per hour squared? Use 12 inches equals to 1 foot and 5280 feet equals to 1 mile. Okay, here we have the rate, that is 33 inches per second square. We have to convert this one to miles per hour square. Okay, we have to convert the inches over here to miles, and we have to convert the second square to r square. Okay, we know that 1 mile equals to 5,280 feet. Let me write the stuff over here. That is 1 mile equals to 5,280 feet. Okay, now let's convert the feet over here to inches. We know that 1 foot equals to 12 inches. Okay, now to convert this 5,280 feet to inches, I have to multiply this one by 12. Then I'm getting 5,280 times 12. When I multiply this one by 12, it will become inches. Let me write the stuff over here. Then I'm getting 1 mile equals to, let me multiply this 5,280 by 12. When I do so, I am getting 63,360 inches. Okay, now let me divide both sides of this equation by 63,360. Let me do it. 63,360. Okay, here this one will cancel. I'm getting 1 over 63,360 miles equals to 1 inch. Okay, here I got the number of miles that is equal to 1 inch. Okay, now let's do the same thing for the time. Okay, here let's take that 1 hour. We know that 1 hour equals to 60 minutes. Okay, if I want to convert the minutes to seconds over here, I have to multiply this quantity by 60. Okay, now let me write the stuff on the left side as it is. Let me multiply this 60 minutes by 60. When I multiply this one by 60, it will become seconds. Then we get 1 hour equals to 60 times 60 is 3,600. That is 3,600 seconds. Okay, now let me divide both sides of the equation by 3,600. Let me do it. Okay, here 3,600 will cancel out. I am getting 1 over 3,600 r equals to, on the right side we have 1 second. Okay, but we have to get the quantity for second square. Okay, now let's square both sides of this equation. Okay, let me do it here square. Okay, now we can take this exponent for this, and this, and I'm getting 1 square over 3,600 the whole square times r square. On the right side, 1 square, second square. The value of 1 square is 1 divided by 3,600 square times r square equals to, the value of 1 square is just 1. That is 1 second square. Okay, I got the stuff that is equal to 1 second square equals to 1 over 3,600 square times r square. Okay, now let me go to the given rate over here. So we have 33 times, and we can consider this inch as 1 inch, and this is 1 second square. Okay, we know that 1 inch is equal to 1 over 63,360 miles. Let me plug in this stuff for 1 inch over here. Then I'm getting 1 over 63,360 miles. And divided by, and for this 1 second square, we got the stuff for 1 over 3,600 square times r square. Let me plug in the stuff over here. That is 1 over 3,600 square times r square. Okay, 33 times. We can take this fraction as it is. That is 1 over 63,360. And we can change the division over here as multiplication. Let's get reciprocal for this one. Then I'm getting 3,600 square by 1, and we can write this stuff as it is. That is miles per r square. Okay, here I got the rate in miles per r square. We can evaluate the value of this expression using calculator. When I do so, I am getting 6,750 miles per r squared. We have a system of two linear equations. In the given system of equations, g and h are constants. The system has no solution. The ratio g to h is equivalent to the ratio 15 to k, where k is a constant. What is the value of k? Using the given information, we have to find the value of the constant k. Since we have a system of two linear equations over here, let me consider a system of two linear equations in standard form. That is a1x positive b1y equals to c1. Here we have a linear equation in standard form. We consider this one as standard form because we have x term and y term on one side of the equation and constant on the other side of the equation. Let me consider another linear equation in standard form, that is a2x positive b2y equals to c2. Here we have a system of two linear equations in standard form. Now let me get the ratio of the coefficients of x. Then I'm getting a1 over a2. ratio of the coefficients of y, b1 over b2, ratio of the constant terms, c1 over c2. Okay, if the system of two linear equations in standard form has no solution, then the ratio of the coefficients of x, the ratio of the coefficients of y will be equal, and both these ratios will not be equal to the ratio of the constant terms. Okay, now our first work is to get both the given equations in standard form. Before that, we have to get rid of the fractions that we have in the given equations, so that the calculation process will be easier. Okay, now let me take the first equation, that is g over 4 times x and negative 15 over 4 equals to h over 4 times y negative 3 over 2. Now to get rid of the fractions, we have to get rid of the denominators. Here we have 4 denominators of 4, 4, 4 and 2. The least common multiple of these denominators is 4. When I multiply both sides of this equation by 4, I'll be able to get rid of all the denominators. Then the fractions will be no more. Okay, now let me multiply both sides of this equation by 4. Okay, now let me do it. Now we can distribute this 4 to this one and this one. Then I'm getting 4 times g over 4 times x negative 4 times 15 over 4 equals to, we can distribute this 4 to this one and this one. Then I'm getting 4 times h over 4 times y negative 4 times 3 over 2. Okay, here this 4 will cancel out, here 4 will cancel out, here 4 will cancel out. 2 goes into 2 one times and 2 goes into 4 2 times. We have gx negative 15 equals to hy negative 6. Okay, now let me continue over here. Let me take this equation as it is. That is gx negative 15 equals to hy negative 6. Okay, here to get this equation in standard form, we have to get the x term and y term on one side of the equation, usually on the left side, and constant term on the other side, that is on the right side. Okay, now let's get rid of this y term on the right side. For that, we have to subtract hy from both sides of the equation. Now to get rid of the constant negative 15 on the left side, we have to add 15 to both sides of the equation. When I do so, this positive hy, negative hy will cancel out, negative 15, positive 15 will cancel out. I am getting gx negative hy on the left side. On the right side, when I simplify this one, I am getting positive 9. Okay, here I got the first equation in standard form. Okay, now let me do the same thing for the second equation. First, we have to get rid of the denominators 2, 3, 6 and 3. The least common multiple of these denominators is 6. Okay, we can multiply both sides of this equation by 6 to get rid of the denominators. Okay, now let me do it. That is 6 times negative 9 over 2x positive 11 over 3 times y equals to 6 times negative 7 over 6 negative 10 over 3 times y. Okay, now we can distribute this 6 to this one and this one. Then I'm getting 6 times negative 9 over 2x positive 6 times 11 over 3 times y equals to 6 times negative 7 over 6 and negative 6 times 10 over 3 times y. Okay, here 2 goes into 2 one times and 2 goes into 6 3 times. Here 3 goes into 3 one times and 3 goes into 6 2 times, and 6 will cancel out. Here 3 goes into 3 one times and 3 goes into 6 2 times. 3 times negative 9x is negative 27x, and here 2 times 11y is positive 22y equals to negative 7. Negative 2 times 10y is 20y. Okay, now let me add 20y to both sides to get the equation in standard form. So here negative 20y, positive 25 will cancel out. I am getting negative 27x. When I combine them, I am getting positive 42y equals to negative 7. Okay, here I got both the given linear equations in standard form. Okay, now let me erase the stuff and continue the problem. Okay, here we have both the given linear equations in standard form. Now let me get the ratio of the coefficients of x, that is g over negative 27. Ratio of the coefficients of y, negative h over 42. And ratio of the constant terms, that is 9 over negative 7. Okay, here there is an information, the system has no solution. Already we have discussed the stuff we have over here. When we have a system of two linear equations in standard form and the system has no solution, the ratio of the coefficients of x, the ratio of the coefficients of y will be equal, and both these ratios will not be equal to the ratio of the constant terms. So the same stuff we can consider over here, because this system has no solution. The ratio of the coefficients of x, the ratio of the coefficients of y are equal, and both these ratios are not equal to the ratio of the constant terms. Since these two ratios are equal, we can consider this particular part, and we can write this ratio g over negative 27 as a negative g over 27. On the right side, we can take this one as it is, that is negative h over 42. We find negative sign on both sides of this equation. We can multiply both sides of this equation by -1 to get of the negative sign on both sides. Okay, when I multiply both sides of this equation by -1, I am getting g over 27 on the left side. On the right side, we have h over 42. Now let's consider the information we have over here. There is a ratio g to h is equivalent to the ratio 15 to k. Here we have some information about the ratio g to h. Since we have the ratio g to h over here, we can try to get a g over h here. Already we have g in numerator. Instead of 27, we need h in denominator. How do we have to get h in denominator? For that, we have to multiply both sides of this equation by the fraction 27 over h. Let me do it on the left side over here, 27 over h. Okay, 27 goes into 27 one times, here the same. And here h goes into h one times, and here h goes into h one times. And for both 27 and 42, we have the greatest common divisor 3. That is 3 goes into 27 9 times, and 3 goes into 42 14 times. Okay, here 1 times g is z, h times 1 is h. I am getting g over h on the left side, and 1 times 9 is 9, and 14 times 1 is 14. Okay, here I got the ratio g to h, that is equal to 9 over 14. Already we have the ratio g to h over here. That is the ratio g to h is equivalent to the ratio 15 to k. So g over h equals to 15 to k. So this one 9 over 14 and this one 15 over k. Both of them are equal to the same stuff, that is g over h. Now what we can do is we can equate these two stuff. Okay, let me do it. 9 over 14 equals to 15 over k. Now we can do cross multiplication. Then I'm getting 9 times k equals to 15 times 14. Now let me divide both sides of this equation by 9. Here 9 will cancel out, and for 15 and 9 we have the greatest common divisor 3. That is 3 goes into 9 3 times, and 3 goes into 15 5 times. I'm getting k on the left side. On the right side, 5 times 14 is 70. That is 70 over 3. Okay, here I got the value of k. It is 70 over 3. Which of the following expressions has 6x negative 5b as a factor, where b is a positive integer constant? Okay, here we have a linear expression, and in the given answer choices, we have quadratic expression, and we have to find the quadratic expression which has 6x negative 5b as a factor. Okay, usually when we factor a quadratic expression, we'll be getting two linear factors, and one of the linear factors is over here, and once I get the other linear factor, I can multiply the two linear factors and I get the required quadratic expression. And when I go over the quadratic expressions in the given answer choices, in all the quadratic expressions, we have the same leading term, that is 24x squared, and the same constant term, that is a negative 15b. Okay, now let me take the given linear factor, that is 6x negative 5b. Now my aim is to get the other linear factor. Okay, what should I write over here so that when I multiply the 6x and the stuff over here, that is equal to the leading term 24x squared. So it's very clear, I have to write 4x. When I write 4x over here and I multiply the 6x and 4x, that is equal to 24x squared. That's the leading term in all the answer choices over here. Now, what should I write over here so that when I multiply this negative 5b and the stuff over here, that is equal to the constant term that we have in all the answer choices, that is negative 15b. It's very clear, I have to write a positive 3. When I multiply negative 5b and positive 3, I am getting negative 15b that we have as a constant term in all the answer choices. Okay, here I got the two linear factors. Now let's multiply to get the quadratic expression that is equivalent to this one. Okay, we can multiply these two binomials using the FOIL method. Let me multiply the first terms. 6x times 4x is 24x squared. Let's multiply 6x and positive 3. That is outer terms. I am getting 6x times 3 is a positive 18x. Now let's multiply the inner terms. Negative 5b and positive 4x. I am getting negative 20bx. And now let's multiply the last terms. Negative 5b and positive 3. Then I am getting negative 15b. Okay, let me write it over here, 24x squared. When I consider these two terms, in both the terms we find x, we can factor x out. Okay, when x is factored, we are left with 18 in the first term, and negative 20b in the second term. That is 18 negative 20b times x negative 15b. Okay, here I have factored x out from these two terms. And the question says b is a positive integer constant. Okay, now let me write the possible values for b so that it is a positive integer constant. Then we have 1, 2, 3, 4. Okay, here all the values are positive and all of them are integers. Okay, now let me consider the least value of b, that is 1. When I plug in 1 for b over here, it will become 20. That is, we have 18 and negative 20. Then it becomes a negative value. Okay, even when I consider the smallest value of b, we get a negative coefficient for x over here. In case I consider the other values of b, for example, if I consider second value of b, 2, when I plug in 2 over here, 20 times 2 is 40, that is I'm getting 18 negative 40. Again, I'm getting a negative value. Okay, for all positive integer constant values for b, I'm getting a negative coefficient for x. Okay, when I go over the answer choices, in two answer choices, we have negative coefficient for x. In answer choice A and in answer choice D. We can reject answer choice B and answer choice C. Okay, which one is correct, A or D? Okay, now let me take the coefficient of x in answer choice A, that is a negative 22. And let me equate to the coefficient of x, what we got over here, that is 18 negative 20b. We can do the same thing for the coefficient of x in answer choice D, that is this negative 484 has to be equated to the coefficient of x over here. Okay, then I'm getting negative 484 equals to 18 negative 20b. Now we have to solve for b in both these equations, and we have to consider the one where we get the value for b as a positive integer constant. Okay, now let me solve for b in the first equation. Let me subtract 18 from both sides of the equation. Then positive 18, negative 18 will cancel out. I am getting negative 40 on the left side. On the right side, we have negative 20b. Let me divide both sides of the equation by negative 20. Then this negative 20 will cancel out. Here negative will cancel out. When I divide 40 by 20, I am getting 2. On the right side, we have b. Okay, here I got the value of b as 2. It is a positive integer constant. Anyways, let's solve for b in this equation. Let me subtract 18 from both sides of this equation. Then this 18, negative 18 will cancel out. I am getting a negative 502 on the right side. On the left side, we have negative 20b. Let me divide both sides of this equation by negative 20. This negative 20 will cancel out. Here negative will cancel out. Let me divide 502 by 20. I am getting 25.1. Okay, in both the equations, I am getting a positive value for b. But only in the first equation, I get an integer constant, that is positive integer constant for b. When I consider this negative 22 as a coefficient of x at the place of 18 negative 20b, I am getting a positive integer constant for b. So answer choice D is incorrect. The correct answer choice for this question is A. The function f is defined by f of x equals to a times the square root of negative x positive b, where a and b are constants. In the xy plane, the graph of y equals to f of x passes to the point 5, 0, and f of negative 12 is greater than f of negative 7. Which of the following must be true? Okay, here we have the function and also we have the information, that is y equals to f of x. Since we have y equals to f of x, let's replace f of x in the given function by y. Then I'm getting the equation y equals to a times the square root of negative x positive b. And the question says that the graph of this equation passes to the point 5, 0. Then we can plug in this exponent 5 for x over here and y coordinate 0 for y over here. Then I'm getting 0 equals to a times the square root of negative 5 positive b. Okay, here on the right side we have product of two quantities, a and square root of negative 5 positive b, and the product equals to 0. Whenever the product of two quantities equals to 0, then the first quantity has to be 0 or the second quantity has to be 0 or both of them may be 0. Okay, if the first one is 0, we get a equals to 0. If the second one is 0, we have square root of negative 5 positive b equals to 0. Now let's solve for b in this equation. First we have to get up the square root. Let me square both sides to get up the square root. Okay, here the square root and square will cancel out. I am getting negative 5 positive b equals to the value of 0 square is 0. Now let me add 5 to both sides of the equation. When I do so, This negative 5, positive 5 will cancel out. I'm getting b on the left side. When I simplify on the right side, I'm getting 5. Okay, here I got the values for a and b, that is a equals to 0 and b equals to 5. Now, let's consider the given function f of x over here, that is f of x equals to a times the square root of negative x positive b. Here we got the value of a, that is a equals to 0. When I plug in this 0 for a over here, it will be multiplied by the square root. Then we get f of x equals to 0, but it is not possible. So the value of a equals to 0 is not possible, that is a is not equal to 0. But here the product of these two quantities equals to 0. And I'm pretty sure a is not equal to 0, then this quantity must be 0. In that case, we got the value of b, that is b equals to 5. Now we have two results. One is a is not equal to 0 and b equals to 5. When a is not equal to 0, then the value of a must be either positive or negative. How do we have to know? We have to use this information, that is f of negative 12 is greater than f of negative 7. Using this information, we can know whether the value of a is positive or negative. Then we can verify the given answer choices. Okay, to do that, let's go to Desmos graphing calculator. Here we have Desmos graphing calculator, and the function in the question is over here. And in this function, already we got the value of this b, that is 5. Now let me plug in the value of b over here. Then the given function becomes a times the square root of negative x positive 5. And also we have this information in the question. Now let me give the function as input to get its graph. Okay, now let me take f of x equals to a times the square root of negative x positive 5. Okay, now we have a slider to get the value of the constant a. When I click on a, I'll be getting the graph over here. Okay, already we know that a is not equal to 0. A may be positive or negative. Okay, here let me guess that a is negative. Then we have to move the slider to the left. When I move the slider to the left, I got the graph way over here. Now let's use this information. Okay, this f of negative 12 is the value of y when x equals to negative 12, and this is the value of y when x equals to negative 7. Now let me get the point on the graph corresponding to the value negative 12 of x. Okay, here we have negative 12 on the x-axis. Corresponding to this value of x, I am getting this point over here on the graph. Now let me get the point on the graph corresponding to the value negative 7 on the x-axis. Okay, here we have negative 7 on the x-axis. Corresponding to this value, I am getting the point on the graph over here. Okay, when I take x equals to negative 12, the value I'm getting the point on the graph is below the point when I take x equals to negative 7. So clearly the value of y at this point is less than the value of y at this point. That is, when x equals to negative 12, the value of y we get is less than the value of y when x equals to negative 7. That is, when I take a negative value for a, this f of negative 12 is less than f of negative 7. But that's not true. The information says f of negative 12 has to be greater than f of negative 7. Okay, then a is not negative value, it has to be positive. Now let me move the slider to make the value of a as positive. Okay, now when I make the value of a as positive, okay, now let me get the point corresponding to negative 12 on the x-axis. It's over here, and this is a point over here. Now let me get the point corresponding to negative 7 on the x-axis. Okay, now let me get the point. Here we have negative 7 on the x-axis. So this is the point we have over here. Clearly, the y value at this point is greater than the y value at this point. That is, f of negative 12 is greater than f of negative 7. Okay, using this information, we get that a is a positive value. Already we know the value of b, that is 5. Now let me plug in the value of b in the given answer choices. Okay, when I plug in b equals to 5 over here, I am getting a less than f of 5. And here we get a is greater than 5. And here we get f of 3 is less than f of, when I plug in 5 for b over here, negative 2 times 5 is negative 10. And when I plug in 5 for b over here, I'm getting a less than 5. Okay, here we got that a is positive, but I'm not sure what is the exact value of a. I can use a slider over here to get bigger positive values for a, like 5 or greater than 5. Anyways, so whatever positive value we have for a, this value f of negative 12 is greater than f of negative 7. So we are not able to get the exact value of a. So the only thing what we can get is the value of a is positive. Okay, here, now let's verify the given answer choices. Now let me go to the answer choice A. Here we have the stuff that is A is less than f of I. Okay, we can get the value of this f of I. We have to plug in this 5 for x over here in the given function. When I plug in x equals to 5 over here, we get negative 5, positive 5 inside the square root. It will become 0. 0 times A is 0. That is the value of this f of I is 0. We know that A is positive. Here we get the result a positive value less than 0. It's not true. We can reject answer choice A. Now let's go to answer choice B. We have A is greater than 5. We know that A is a positive value, but we do not know the exact value of A. If A is less than the positive value 5, then this is false. If A is greater than the positive value 5, this is true. But we are not able to conclude whether the stuff we have in answer choice B is true. So we can reject answer choice B. Now let's go to answer choice C. We have f of 3 is less than f of negative 10. We know that f of 3 is the value of y when x equals to 3, and f of negative 10 is the value of y when x equals to negative 10. Okay, now let me go to the point corresponding to x equals to 3 on the graph. Okay, here we have 3 on the x-axis corresponding to x equals to 3. This is a point we have on the graph. And also let me go to the point on the graph corresponding to x equals to negative 10. Here we have negative 10 on the x-axis, and this is a point corresponding to x equals to negative 10. Now we have to compare the y values at these 2 points. Clearly, the y value at this point when x equals to 3 is less than the y value at this point when x equals to negative 10. That is, f of 3 is less than f of negative 10. So the correct answer choice for this question is C. Anyways, we can verify answer choice D, and we can reject answer choice D for the same reason for which we have rejected answer choice B. Because here we have A is less than 5. We know that A is a positive value. Okay, when A takes a positive value less than 5, this is true. When A takes a positive value greater than 5, this is false. So we are not able to conclude whether the stuff in answer choice D is true or not. So we can reject answer choice D. Therefore, the correct answer choice for the given question is C. Hello everyone, Ramachandran again. Hope you'd have understood all the 10 hard SAT math problems explained so far. Keep watching our YouTube channel to have more digital SAT math problems. And also you can go to the URL given over here to get more content on digital SAT math. Thank you.